right, here we go. So it's no secret, I think, that Google Maps platform loves DeckGL. I actually want to start by once again thanking this community uh, for, uh, for using the Maps JavaScript API with DeckGL. Google Maps is absolutely a better platform for developers because of the DeckGL community. Uh, in fact, I flew all the way to Spain last year, basically just to tell you that. So, I mean, and why wouldn't we? I know that for everyone here, this is a little bit old hat. You've seen these visualizations before, but at the time, we really felt that uh, that DeckGL was one of the only libraries out there that was fully making use of the capabilities, the newer capabilities of WebGL overlay view, as well as the vector map to show really what is possible with Google's base map. But I also went to Spain last year for this summit with a bit of an ulterior motive, and that was to talk about what React support for the Maps JavaScript API might look like. So we sat down with a few of the DeckGL maintainers and members of the vis.gl steering committee last year, and we started to talk about what would it take, what would a good React component library look like for the Maps JavaScript API. And from that, we built React Google Maps, which is now available in alpha as a new project under vis.gl. So, we donated this code base to the OpenJS Foundation, to vis.gl, for a couple reasons. One was, of course, we wanted to get the expertise of the maintainers of DeckGL and vis.gl to help us figure out, what would a good React component library look like for all developers in general, but also what it would look like so that we could have full proper support of DeckGL, which, as you all know, is a React app. We even have a website which is up as of this morning. Thank you, Martin. So that you can check out. So this, like I said, this is now available in alpha, and you can try it out today. It's on npm. I think we're at version 003 already, or something like this. And it looks like this. So I feel like it's kind of funny because all yesterday and today you've been seeing a lot of really complex code and complex integrations with DeckGL, and what I'm showing here is what I feel like is a great simplification that makes it much easier for React developers to utilize the Google base map. So this is just a basic React app. The API provider component loads the Maps JavaScript API. There's a map component that you get where you can set the different properties of the map, which is a child component of that, and then the marker. So this is just a basic map with a marker. Nothing too complicated. As part of this library, we introduce a set of components, like I said, API provider, map, as well as the ability to load multiple maps. This is something that's always been a difficulty, especially for React developers. And then many of the base UI components of the map. So marker, info window, and then the new advanced marker element and pin element that GA'd this year. In addition to components, we also introduced a set of hooks to make it easier for you to both work with the map instance, as well as many of the libraries and services that are included with the JS APIs to give you access to Google's geospatial data and place data. So things like autocomplete widget, place search, directions, geocoding, etc. And these are all available as part of the same library. And it works with DeckGL, which is really awesome. Not quite as awesome as this slide, but pretty great. It was really important to when we first sat down to spec this out. Like I said, we've always felt that DeckGL is a React app where if we could support that, we could kind of make it easy and support any React developer. So this is what it looks like working with React. So we're defining, as a part of the initial view state, we're defining the state of the map, passing those values to the options that load the map as well. You can see that there's a map ID here, which is how you get the vector map, which you're going to want if you want all of the niceness of DeckGL. And then I'm missing a bracket there, but that's okay. So again, the API provider is loaded, and then Deck is loaded as a child component of that. We pass it the same initial view state. One other thing to mention here is this on view state. Is that for on view state change, you have to pass in this limit tilt range method, which comes from the library. And basically, what it does is it just ensures that the tilt the tilt of DeckGL's UI state never goes outside of the range of Google's base map, which does not tilt quite as far as other base maps that are available. And then the map is loaded as a child component of Deck. And the really great thing about this is that they share the same view state. So when you update the view state of DeckGL of the app, you also update the view state of the map automatically, which is awesome. I want to just also take a minute to thank a few people. This slide is actually my attempt to pass off all technical support related questions to Martin, sitting over here, and the other members of the UV Labs team. But this project came together as a collaboration with a whole bunch of people, but in particular Sabrina and Patrick and Martin from UV Labs, who did basically all of the development work for this and worked with us and our engineering team to spec out the API surface and all of the internals of the library. Felix Palmer from Cardo, who's provided an immense amount of guidance, not just for this project, but for many different things related to DeckGL, and Xiaoji Chen from the steering committee, who was nice enough to sit down with me in Spain and entertain this idea in the first place of building this library and making it a part of vis.gl. So thank you very much for all of your work and your guidance. It's been really invaluable. Again, get it on NPM, and there's the GitHub repo as well as the website. Please comment on the alpha. We really want to continue to evolve this library. We're certainly not done with it yet. Find any bugs and help us make Google Maps better for every React developer, not just for DeckGL users. And with that, I will pass it off to Travis to talk about 3D tiles.
Thank you, Alex. Thank you, Alex. So I am Travis McPhail, also known as the Crazy Maps Engineer inside of Google. That's my official job title. So I'm gonna talk to you a little bit about our photorealistic 3D tiles offering we launched earlier this year. Sorry, it just immediately jumped to the skip the slide. But over the past couple of years, there's been a lot of improvements, particularly on our web-based map offering to developers, uh, starting from bringing vector map experience to web developers, to including WebGL overlay in that offering, all the way to our experimental release of our photorealistic 3D tile data. For those that aren't aware, that is the data that fuels and powers Google Earth. We're externalizing that tile data asset directly. And just to talk a little bit about that, so our Earth application, we have our own internal representation of this data for reasons, but we chose to not externalize that internal format, but anchor on an open standard. And so we chose to go with the 3D tile OGC standard, so that developers had the ability to visualize our 3D map with renderers that support the 3D tile spec. Or if you want to, there's a 3D tile spec, you can build your own implementation from the ground up. And with this direct access to our tile data developers, you get more flexibility in controlling the visual interfaces and interactions that can be more tailored to your brand or your use cases. So leading with 3D tiles, we worked a lot with Cesium, in particular Cesium.js, to improve upon the rendering performance of our 3D tile data. And because our photorealistic 3D tiles already have data attribution, Cesium seamlessly handles that attribution, as well as has a collection of camera orbital controls and geofencing capabilities at your disposal with that offering. And just to kind of show you what kind of like the minimal amount of work that you need to do to incorporate our photorealistic 3D tile offering into Cesium.js. You create a Cesium viewer, pretty standard, and you're adding just a regular Cesium 3D tile set. The URL is the root URL for our 3D tiles product, plus your API key. And one very important thing, show credits on screen. Please set that to be true. Don't want any hiccups. And what you get is something like this. You get the like full access for our 3D data that powers Google Earth, which is designed specifically for use cases at the city block level or higher. It's fairly comprehensive. We have this 3D coverage in a little over 2,500 cities and 49 countries. So you get a decent amount of coverage with this offering. And because it's also, we do internal alignments with our other services like our Places API and directions, you can actually directly use those services and overlay those results onto this 3D map substrate. Yeah, there's one more thing. So going back to this timeline, this is not actually complete. There's one thing that is really not conveyed here, and that is how this community has been integral in the evolution of the Google Maps platform, particularly on the web, really helping us test and vet and iterate on the changes that we brought to the platform, and really shown web developers in particular kind of like the art of the possible. And our photorealistic 3D tiles is no different. So when we launched the experimental release of 3D tiles earlier this year, we knew that we didn't want we wanted more options for developers outside of Cesium. And so we worked with the wonderful maintainers of DeckGL to integrate our 3D tile offering into DeckGL. And so here's an example. Once again, much like Alex, I don't have a complex example. We like this. We like simple integrations these days, and so our 3D tile offering works with the DeckGL's Tile 3D layer. Once again, you just you set the root URL for the tile set and your API key, and DeckGL handles the rest. And because it is a layer, you can composite composite this Tile 3D layer with other layers of DeckGL's visualization toolkit. And so here's an example from the great folk over at Cardo. Felix, shout out to you. I think Alberto was talking about this demo in his presentation, but this is just overlaying um, vegetation data over the 3D mesh substrate, overlaying color coding buildings by their proximity to vegetation, I believe. So please give these applications a try. UB Labs has made the 3D Tiles web app, which is Cesium-based demo, and Cardo has made the 3D Tiles Cardo.com, which is a DeckGL example. So please, all of you geospatial 3D experts out there, have fun. Let us know. Let us know how it goes. And with that, I will say thank you because I know you're probably hungry. All right.